today we're going to talk about some different parts of a graph, specifically the zeros, the intercepts, the max, and the min. Right? So your objective today is, I will be able to identify parts of a graph. We're going to start with zeros. Zeros can also be called roots, solutions, and x-intercepts. All four of these are the same thing, right? They got four different names for the same thing. Usually it depends on what you're doing with the points that you're looking for. If you're working with quadratics, you'll use roots or solutions. If you're doing polynomials, they're usually zeros. They're all the same thing, no matter which name you use. You'll always find them on the x-axis. Right? It's just every place the graph crosses the x-axis. Right? So in the first example, we have 1, 2, 3 points. In the middle one, we just have 1. In the last one, we have 2 points. Right? So what we do to say what they are is we just start listing. Like this point is -2, 0. This point is 0, 0. And this point is 2, 0. In the middle graph, we have 6, 0. 6. And on the last one, we have -3, 0, and +3, 0. So you're just listing off all the points on the x-axis. The next thing is y-intercept. This is the one on the y-axis. So that one going up and down. Sometimes it'll say f of x instead of y, but it's still a y. So again, you're just listing off all the places it crosses there. So our first one, it only crosses this one time on 0, 0. This one, it'll cross here on 0, 1. And here we'll have 0, 3. And 0, -3. If you noticed, y-intercept will always be 0, something. The x-intercepts are always something, 0. That'll always be the case. Just because x-axis and y-axis work that way. So that's those two. Those you've done several times since Algebra 1, because I know that. The next one is max and min. Now, there are two types of max and min. Generally, in Algebra 1 and Geometry, and even in Algebra 2, we don't really talk about the differences between the two, but we're going to need to know the differences now. So we have two types. There's relative max and min, and then there's absolute max and mins. Relative max and mins are the highest or lowest in that area. So maybe not the highest and lowest of the full graph, but in a general area. So I'm going to give you an example here. So this graph, once we start getting up in pre-cal, we get graphs with lots more things going on than we used to have, right? Polynomials have lots of ups and downs and humps and whatnot. So relative max and min. So we'll start with max. This point here, it's not the highest point because of these up and down arrows over here. But in this general area, it is the highest. So this is a relative maximum. Down here, these 2 points, we can't say they're minimums because they're even with each other. They're not the minimum of the graph. There's 2 of them. So these would be relative. I can't spell relative today. And then that would also be a relative min, since they're even with each other. So that's what relative is for. Absolute is when it's the highest or lowest point of the whole graph. the highest or lowest of the whole graph. So I'm going to draw an example maybe. So maybe this graph. So these arrows now are going side to side, right? Which means this point up here, this is the tallest point of the whole thing. There's nothing higher than that. So it is the absolute max. And down here, nothing's lower than this. There's no other humps or anything, so it's the absolute min. Like that. That's the difference between relative and absolute. What we're going to do is look at a few graphs and just go over the three different things. So we'll look for zeros, y-intercepts, and we'll look at the maxes and mins that we have. And we're just going to look at all three of those. So for zeros on my graph here, I have 4 of them. 1, 2, 3, 4. Right? We're just going to list all 4 of those. So we're going to estimate these decimals. They don't have to be exact. Just try to get them as close as you can. For example, the first one would be about negative 5.5. Second one would be like negative 2.5. That next one, it's not on 0, 0. I'm going to call it 0.1. It's very close. And then the last one is like, 5.3 maybe? Somewhere in there. That's all our zeros. Our y-intercept is here. That is not on 0, 0. It's a little below, so I'll call it negative 0.1. For that. Max and min, we're going to have, for max, we're going to have 2. One's a relative and one's an absolute. So we're going to have a relative max at, and then we'll just name the point. So that's this one here. We'll just call that negative 4.140. Right, that's a relative. Absolute is that top point there. So we got 3 and 110. And then for minimum, we've got the arrows here, but we do have this point. Since the arrows are below it, it can't be the absolute min, it's going to be the relative min. And we'll estimate that's about, what, negative 1, negative 20. There we go. Right, so we did all 3 for this graph. All right, we had some of everything. So we're going to look at another one. So what I want you to do this time is pause the video, write down the 3 things, and then unpause and see how you did. Okay, so for zeros, we've got 2. Got 1 on 0.80 and 1 on 5.20. Y-intercept, 0, negative 4. Max and min, we only have 1. We have no minimums because of the arrows and there's no bumps down there. We do have a absolute max at 3.5. Just the 1 max for that one. Alright, I'm going to do one more. So again, pause the video, try it yourself, and then unpause to see how you did. Okay, so for zeros, we only have 1 0 this time. It's on 3.10. Our y-intercept is on negative 0, negative 3. we have one relative max. It's actually the y-intercept, so 0, -3 again. That's a relative max there. And we have a relative min at this bump here, be 2, -7. And there we go. Alright, so just a reminder, we are having a quiz tomorrow. It will be about everything from this week. Please come to office hours if there's something that you need help on. You can come tomorrow if you want before you take the quiz. And we can